Here's an example for completing the square. If we're given a polynomial, and here I've written x squared plus 6x minus 4, this is in the investigation we did. If we try to factor this, we see that it won't factor nicely. We have x's in the first spot, and we need to look at this -4. Factors of -4 are either 1 and 4 or 2 and 2. And neither one of these factors will give us 6. So we know that we can't factor this, so we need to do something called completing the square. And what you do is, I'm going to rewrite my equation, x squared plus 6x minus 4. Let's look at this box method. You're going to look at the first two terms. So we know x squared goes in the first box, and that's x times x. To figure out what goes in these last two spots, we know these middle terms have to add up to 6x. And these numbers are going to be the same number. So we know that that would be 3. So 3x and 3x will give us 6x. Now, to complete the square, which is why it's called that, what would complete the square going here? Well, it's 3 times 3, so we know 9. So when rewriting this, we write x squared plus 6x plus 9, because that would complete this square, and then minus 4 off to the side. And remember, if you add 9, you need to subtract 9. So now we factor this x squared plus 6x plus 9, and we see that that's x plus 3 quantity squared. And then the last thing to do is to group this -4 minus 9, and so that's -13. So we went from having a polynomial that wouldn't factor to having one that's now in vertex form.